Oh, that's what on earth? Okay. That was weird. It said there was gonna be like some kind of technical problem and maybe kick somebody out of the meeting. So if anybody got kicked out, hopefully nobody got kicked out. Please rejoin. It said you could rejoin. I don't know why it would kick someone out because we're recording. But anyhow, that's extra fun. Limits. Find the limit of a function written in function notation. So this is actually really no different than, or not too different than finding our limit using a graph, just using a function instead, written out. So let's go ahead and grab your notes and we'll get started here. Okay, limits of functions. So we've already kind of seen, like earlier in the year, we would see things like the limit as x goes to infinity of a function and stuff like that. And even that is a little bit more complex than what we're working with today. So today we're going to see I guess cases where the limit as x approaches some value a of a function f of x is equal to f of a. These are the kinds of cases that we will be seeing today. So really, this is a lot of this is going to be about evaluating a function at a value like a to get to figure out what that function value is, because if the function value exists there, that is typically the limit. Okay, so let's get started with an example. So we'll do the limit as x approaches -2 of 2x plus 7 over 4x. Okay, so whenever we're asked to do something like this, all we really have to do is take -2 and plug it in for x. So we get 2 times -2 plus 7 over 4 times -2. So we get -4 plus 7 over -8, which is 3 over -8, or -3/8. Okay. So hopefully these will be, fairly simple to do, at least to start with here. Towards the end of today and then leading into tomorrow, we'll see some more complicated cases where we get to figure out, what to do if we end up with something called indeterminate form. But until we get to there, let's do another one or two of these real quick. The limit as x approaches 0 of, we'll go with 4x plus 1 squared minus 1 over 2. We'll go actually 2x plus 3, just to make it interesting, give us somewhere else to plug in an x. All right. So here we're just taking 0 and plugging it in for x. So we have 4 times 0 plus 1 squared minus 1 over 2 times 0 plus 3. So in this case, 4 times 0 is 0. 0 plus 1 is 1. 1 squared is still 1. We have 1 minus 1 over 3, which is 0 over 3, which is just 0. Okay, so hopefully we're kind of getting the pattern here of what's going on. I'm going to give you guys one or two of these to try, and then we'll take a look at a few other things that can happen here. Or sorry. Okay, so these are kind of the basic cases. Okay, so go ahead and try those two real quick. When you think you've got them, put "got it" in the chat. All right, a couple people think they have it so far. So for the first one there, we're making sure we plug in 4. 4 squared gives us 16. 2 times 4 is 8, so we get 16 minus 1 over 8, which is 15/8, and you can just leave it like that. Or at least for me, you can leave it like that. Some people like you to put it as a mixed number or something like that, but really that's the lowest form of the fraction, so that works. For the second one, those of you who think you have it, what'd you get? Anyone want to share with us what they got? -2/7. I would agree with that. So here's how we get there. -1 cubed is -1. -1 on top. And then -1 squared is +1. So we get 4 plus 3, which is 7. So here we get -2/7. Okay. So this is kind of the simple case here, where what you get works out really nicely. You end up with a fraction or an integer of some sort, right? When you plug in the value, you get something that works out fairly nicely. So we're going to take a look now at what happens if we end up with something called indeterminate form. So indeterminate form is when you take the limit as x goes to some value of a function, and usually it's written in the format of a function over another function, like f of x over g of x. And then you end up with 0 over 0. 0 over 0 is considered indeterminate because you can't divide by 0, but also having that 0 on the top, you know, technically, you know, 0 divided by anything is 0, but you can't divide by 0. So we end up with this indeterminate form here. And so when we end up with indeterminate form, there are some things that we can do usually to simplify what we're working with before we take the limit. So if you end up with indeterminate form, you might want to pause and go, okay, let's see if there's some more steps that we can do beforehand, and then try to take the limit again. So usually those steps involve either expanding or factoring or rationalizing the numerator or the denominator. Today we're going to look into expanding and factoring a little bit. Tomorrow we'll look a little into rationalizing the numerator or the denominator, since that takes a little bit more stepwise sometimes. So anyway, I'm going to need another piece of paper. Sometimes we'll get something like this, where we have so this will be example number 3, the limit as x approaches 0 of negative 3x plus 1 squared minus 1 over negative x. Okay. So we might start off by just plugging in 0 and seeing what happens here. So if I plug in 0 on top, we have 0 plus 1 squared, so that would be just 1 squared, minus 1 over negative 0, which is just 0. So this gives us 0 over 0. So we don't want to work with that. Instead, this looks like something that maybe I could expand what's going on the top. So let's try that. We're going to expand the numerator. So to expand the numerator, I am multiplying negative 3x plus 1 times negative 3x plus 1. And we still have that minus 1. So we end up with, let's see, 9x squared minus 6x plus 1 minus 1. And it's still all over negative x. Okay, so let's simplify a little bit further here. And we get 9x squared minus 6x over negative x, because plus 1 minus 1 cancel each other out. Okay. So we're getting closer here to something that we could use. Except if I plug in 0 now, it's still 0 over 0. So the next thing that I want to do is factor out an x, because both of these have a greatest common factor here. And actually the greatest common factor would be 3x, but all you really need to factor out is an x, although you could factor out a 3x if you'd like to. So let's do that. 3x, just factor out the greatest common factor, because why not? So we have 3x, and then we're still left with 3x minus 2, and that's all over negative x. And now something really nice happens. We have an x on the top and we have an x on the bottom that we can cancel. We still have that negative sign, so we want to kind of keep track of that. But this is equal to negative 3 times 3x minus 2. And now we can take the limit of this, since this expression is equivalent to this one, because we just kind of expanded that. We had negative 3x plus 1 squared minus 1 over negative x. We expanded. We factored out the greatest common factor. We canceled the x. And now we're left with this. So now we're going to take the limit as x approaches 0 of negative 3 times 3x minus 2. And when I plug in a 0 here, we get -3 times 3 times 0 minus 2, which is just -3 times -2, which is +6. Okay. So sometimes doing something like that, expanding the numerator, can help us out when we're in a situation where we end up with indeterminate form. Okay. So I know that one was considerably more complicated than the last few we looked at. Are there any questions with that one so far? Any numbers that we're not sure where they came from, steps we're not sure how they happen? Okay. So basically, we're simplifying things. All right. The next one we're going to look at is going to involve a little bit of our old friend factoring. So this one, we're going to take the limit as x approaches -1 of x squared minus 1 over x plus 1. Okay. So as always, to check and make sure that this thing doesn't that this thing doesn't work out nicely to start with, we'll plug in -1 and see what happens. -1 squared is +1. And then we have -1 plus 1 on the bottom. This ends up with 0, and this also ends up with 0. We get indeterminate form. So we do need to figure out something else that we can do here to simplify this. So in this case, expanding the numerator is not really going to help. It's all expanded the way it is. But we could try factoring the numerator. In this case, because we have difference of squares going on here. So that's kind of handy. So when we have difference of squares, we have x squared minus 1. That's equal to x minus 1 times x plus 1. So then we know that x squared minus 1 over x plus 1 is equal to x minus 1 times x plus 1 over x plus 1. Well, that works out really nicely because now we have something on the top and the bottom that we can cancel. The x plus 1 with the x plus 1. So now we're just left with x minus 1. And now we can take the limit as x approaches -1 of x minus 1. And then we just get -1 minus 1, which is -2. Okay. So those are two other scenarios that you guys might see when you end up taking limits here. Any questions from that one? Any numbers we're not sure where they came from or anything like that? Okay. Then I'm going to give you guys a couple to try. And then we'll move on here. Probably start looking at the homework after this. First one. We'll go the limit as x approaches 0 of 2x over -2x, not squared yet, plus 2 squared minus 4. And then the second one, we'll go the limit as x approaches -7. And then x plus 7 over x squared minus 49. Okay, so go ahead and give those ones a try. Let's see. For hints, I would try expanding the denominator here. I would try factoring the denominator there. When you think you've got them, type "got it" in the chat. You're on the right track on the first one if this is how you expanded it, and then saw that you could cancel the 4s. Number 1, if you got -1/4, you are correct. On the second one, you're on the right track if you factored the bottom into x minus 7 times x plus 7. So then we would plug in -7 to this, the 1 over x minus 7, to get -1/14. Okay. So looking at those two, are there any numbers we're not sure where they came from? Any steps we're not sure how they happened? Anyone get something different and they're not sure why? Okay. So on a scale of 1 to 5, 1 being I'm super confused and could use a lot more examples, 5 being this seems pretty easy to me, what are we feeling right now? All right, mostly 4s so far, maybe some 3s. Anyone else out there care to answer? More 3s and 4s. Okay. In that case, let's go ahead and take a look at the homework real quick. It is posted in Google Classroom right now. And it's slightly different than what I had put on the website earlier this week because I realized that F5 was going to take like maybe a minute or two to do. And not that that's a bad thing, but it also doesn't challenge our brains all that much. So F5 is the super simple one. It's the limits of polynomials and rational functions. So all you have to do is plug in the number for x and put whatever you get as your answer. So in this case, 7 times -7 is -49, plus 3 gives us -46. And there's a whole bunch of that sort of question. So that one should go pretty darn quickly. This one, finding limits involving factorization and rationalization, this one you only have to go to a SMART score of 60. Because after 60, it involves a bit of rationalization, which we did not get to today. So we're only going to do the ones that look like the ones we've done today so far, which involves expanding the numerator or denominator, which this is almost exactly the one that we just did on the U-try, or the ones that involve factoring the numerator or the denominator and then canceling something. Okay. So this one, again, you only have to go to 60. The other one, you go to 80. This one, only to 60 for full credit. Any questions, comments, concerns before we go? Okay. Then at this point, if you would like more examples or need help with any of these particular kinds of problems, feel free to stick around. Otherwise, you are free to go and enjoy the rest of your day. Have a good one.